Hey, hello everyone. Welcome to the sixth meeting now. Yes. And the topics we'll discuss today, as usual, there'll be three classes of questions. One is related to quantum mechanics, and that's what we are going to start with. Then we're going to discuss cognitive processes, and finally, the one that actually got lots of votes, most of votes, is universal consciousness. So should be fun. Let's get started. Now, the reason I want to start quantum mechanics and also want to discuss cognitive processes at the same time, because there were some works by Penrose and other collaborators suggesting that quantum mechanics plays a essential role in thinking in cognitive processes. Now, this is a very unconventional way of thinking how quantum mechanics works. However, I do believe there is some truth to it, and we'll discuss that. Not exactly in the way that Penrose and company is thinking about that, but in the way that we were able to explore this possibility in context of quantum mechanics. So let's start with quantum mechanics. It's a really it's one of those subjects that people disagree the most within physics, and also probably least understood. Not mathematically. Mathematically, you know exactly what calculations to do, but least understood conceptually. There are some conceptual questions that cannot be answered. And let me try to explain to you what the problem is first before I start answering questions and discussing it. So basically, the classical physics comes with two postulates. Basically, you describe your state or your state space, and a vector in that space, and then you describe how that state changes, right? So you have a way of describing the state and how it changes. Now, in quantum mechanics, there is a third ingredient that is very different. And you still have a state. It is something that's called a wave function. You still have dynamics of that state, which is called Schrodinger equation. And then you have a third ingredient, observation. So this is the theory tells us that it is incomplete until you tell what kind of observation you're going to make on the system. And by changing the observations, you get different answers. But then the question arises, now, who is the observer, right? Now, if you're outside of the system, if we are all outside of the system making measurement on the system, we can probably all agree what kind of measurement we're going to do, and that's fine. But if you are inside the system, if the universe is the system, then it is there is a difference between me observing the universe or one of you observing the universe. And that's related to something that's called the measurement problem. And if you heard about the Schrodinger cat, paradoxes and things, that this is related to that. Now, many people, because of that, think that quantum mechanics just isn't complete. And so this neural network theory is an attempt to complete it. So what you're saying here, what we were saying is that quantum mechanics is just a certain limit where quantum mechanical calculations make sense, but really underneath of it, there is a well-defined evolution. And the reason really you don't know everything about the system, because there are some hidden variables, and it's sometimes related to something called hidden variable theory. There were different approaches to seeing quantum mechanics, and in this picture, quantum mechanics is an emergent phenomenon. It's not fundamental. It's some just useful way of you to do calculations, right? Now, there were other ways of doing this before neural network theory, but there were problems, in particular. Problems where the complex numbers are coming from, basically. Why is it that the wave function is the right degree of freedom? And just to remind you, wave function is a very strange object. It is like square root of probabilities, but it can not only have a real part, it can also have an imaginary part, and so that's where all complications come from. And of course, just discussing quantum mechanics, showing all of its weirdness, is a topic on its own. But let me just say that within the context of neural network theory, it seems to be an emergent phenomenon. Isn't fundamental. It isn't how the universe works. It is just a useful way of doing calculations in the universe. And then to answer this second question, is possible that some parts of quantum mechanics are fundamental, others are emergent. So I would say that no, it's not possible within this formulation. It is all emergent, but it's only in certain limit, a very specific limit, where system is very close to this learning equilibrium, where the quantum mechanical calculations make sense. Now, I will get back to this when we discuss cognitive processes, but for now, let's see if may have some questions, suggestions. Let's see what the possible reactions are. Go ahead, Revel.
So does God play dice in the universe under neural network theory or not?
Well, okay, so God is the discussion we try to avoid.
That's a metaphor. That's a joke. I mean, it's in the same context that Einstein would use it.
Sure. Yeah. So there is a dice. There is a dice, and the dice is those hidden variables. So there are those things that you do not quite know and you cannot really measure. So there is this stochasticity, but it isn't all. So if it was just a stochastic process and there's somebody just throwing dice, and then there wouldn't be any emergence of quantum mechanics. For quantum mechanics to emerge, you need two things. You need somebody to play dice and try to destroy information, and then there has to be a learning, right? And so then I don't know. So if you want to think about learning as God and destroying information as demon, then there is this balance between the two, where the quantum behavior emerges. So really, you need to have both. You need to have a destruction of information, entropy, and then you need to have also learning. So the two dynamics, they're like two sides of the same coin. And with only
so I'm confused because I was under the impression that if you're talking about quantum information that can't be destroyed, so are you referring to more classical information, or if that's
well, the point is actually cannot. So quantum state, if it is not interacting with the environment, like, if the whole thing is quantum state, and presumably if you think about the universe as the one quantum state, then it always stays in the same, the amount of entropy is always the same, okay? So it's called a pure state. And even if it's not a pure state, it's called a mixed state, the entropy still isn't increased nor decreased. So in quantum system, you are really in a balance where the entropy isn't, and information isn't created nor destroyed. So it's now, of course, we are dealing in the real system that we are trying to build in the real world, like a quantum computer. One of the problem is that quantum information is destroyed. You interact with the environment, and then as a result of that, entropy goes up. So, but if we are like isolating the system, like put it in isolation and like look at it, then the entropy remains constant. So it's in a balance. As much as you didn't know about the system before you started your experiment will be the same amount as you don't know later on. So this is kind of what a closed quantum system is. And then within that system, there are still two effects, right? Entropy decreased and increased, but if you are in equilibrium, they're kind of they're balancing each other. However, it is interesting to think, what if the entire universe is a quantum system and is just described by the Schrodinger equation? And that's what's called the many worlds interpretation of quantum mechanics. It has a problem because in the many worlds interpretation of quantum mechanics, there are just no probabilities. So we cannot talk about
So-
probabilities. There are no different outcomes. The system just deterministically evolves from one state to another. So thinking about the whole universe as a quantum system, probably not a good idea. But there are subsystems that are pretty well described using quantum mechanics. Let's see if there are other thoughts. Again, we are starting with difficult topic, quantum mechanics. We'll move on to something that everybody has opinion on later on. Victor, go ahead.
Are there any thought experiments which can demonstrate the hidden variables hypothesis, so that we just
Good.
can you describe them probably shortly?
Yeah. So the thought experiments, of course, easy to do, but what we want real experiments. Can you actually conduct an experiment and say, look, now the theory isn't completely quantum, and here are the deviations from quantum mechanics. Now, and that is possible, but it's hard because the system goes to equilibrium very fast and remains equilibrium if it's small, and if it's large, it always interacts with the environment and becomes even more complex. So for the time being, I'm not able to design an experiment that would actually show that it's not truly quantum mechanics. However, there is indirect experiment. So with this theory, we're saying that really you would not be able, and it's related to one of the questions, you would not be able to produce a really scalable quantum computer. So basically, and the reason for that is because you do need, as the size of your quantum computer becomes larger and larger, the state space grows exponentially large, and then dimensionality of the state space grows exponentially large, and you really need a lot of hidden variables to be able to model it as quantum mechanics. And so one of the prediction of this would be that really you may be able to create a good enough quantum computer that is capable of performing some kind of calculations, but not really true quantum computer with very many bits, because eventually will be problems with scalability. Like now with classical bits, it's not a problem, right? You need twice as much memory, you build twice as big computer. Maybe processing this information is a different issue, but creating a scalable classical digital computer is not a problem. But there will be a problem with the scalability. Now, let me just mention one thing, because it's very important. For emergence of quantum mechanics from neural networks, it isn't just enough for you to have a neural network that learns and gets to the equilibrium. There are some clever things had to be happening at the level of algorithm. So it's not just any learning algorithm will produce you quantum mechanics. That's of course wrong. And this clever thing within the algorithm is that a system has to create and remove neurons on the go. So a system has to self-identify, here is a useless neuron, I'm going to kill it. And then it would look, say, okay, well, here is a neuron which is really loaded, it needs a help. So let's create neurons. So this ability to create and destroy neurons, which in biology we would know like replication and maybe program death, is essential for the emergence of quantum. And you would only be able to have that emergence if your learning algorithm has that. Now, how did the universe? So if we take this hypothesis that yes, quantum mechanics is emergent, how did the universe figure out that algorithm of creating and destroying neurons? Is a question, right? So, and I don't have an answer for that, because you would have to study dynamically. Well, here it is, a neural network system that is just learning, and then eventually it just discovers the right algorithm to mimic quantum mechanics, and then it makes it capable of performing certain quantum computations. And so that's a possibility.
Does it mean that quantum computer based on neural network, to solve the tasks, it should grow in complexity? If you are saying that,
oh yeah. So
it's not purely power law of
Behavior. Yeah, there is an exponential hidden there. Yeah, absolutely. So there would be an exponential, and that's why I'm saying really have a scalable quantum computer is probably wouldn't be unless. So let me just put one remark. Unless we have access to a bath of those hidden variables outside of the universe, right? So we have our universe with the emergent locality that we discussed, and so we're building this quantum computer, but the computer has access to neurons that are actually outside of this emergent space. If that is the
What do you mean by
possibility,
outside?
yeah.
Can you define what you mean by outside of the universe and how that could possibly be determined?
Yeah, sure. So in this whole picture, originally, when the neural networks start learning, all neurons, remember from, you were not here last time, but okay. Basically, all neurons are disconnected and like deciding who they should connect with, who they should be collaborating. So there is no locality, there is no three-dimensional space, and all the neurons are like, there's no meaning of where they're located. There is no meaning of location, but there is a meaning of connection. And so they're starting establishing connections, and they, figuring out that having maybe one-dimensional structure of neurons like chains is a convenient way of processing information. So here we have one-dimensional space, a chain of neurons. Now the evolution goes on, and then they discover that the two-dimensional, three-dimensional way of communicating is efficient. But it doesn't mean that within this collaboration, all neurons jumped in and say, okay, I want to join your universe. No, there would be a bunch of neurons who collaborate with each other, others don't. And they would be outside of that universe. They would be outside of our three-dimensional space. We wouldn't see them. The only way for us to see those other neurons is to establish connection with them, right? Is to either send them to signal or better receive a signal from them. And we can send a signal to anybody we want, but we will not receive the signal back unless they think it's useful for their task, learning task. And so it could happen that we are building this quantum computer and we are only using neurons that are effectively in this three-dimensional space. But then neurons from the outside figure out that establishing connection with us is beneficial to their learning task. And then they will go, now we have those neurons outside of our three-dimensional emergent space, yet they're contributing to computation that we are performing. But it's always like this, right? Even when we're dealing with organisms, it's either organisms are independent and they live on their own mostly, or they start to collaborate somehow and exchange information. And so there might be potentially that right now our universe is mostly disconnected, is not collaborating with other universes, but since they're also there, at some point we might be able to establish connections and start communicating with them. Maybe we are building here a neural computer, they're building a neural computer, and then all of a sudden connections start to emerge. Now it can be with this completely decoupled universe, which has no connection through the locality, but it can also be a connection with our space, but in some place far away. So some kind of wormholes may be forming, if it is again useful from the point of view of the learning. And so what would be interesting is actually to see and study how this type of experiments here on Earth, where we are creating a neural computer, and there is maybe somebody else creating a neural computer, how is it beneficial from the point of view of the two computers or two subnetworks to actually connect. And a bulk of discussion last time was actually about that. Even languages, like when we figure out a language of communication between people, we just decide that this is a useful way to transfer information between us. And so building new channels of communication is learning. This is a process. Like within this group, we're establishing a new channel of communication, and that makes our group smarter because now we can exchange ideas using the same language. It doesn't actually less important at this stage, less important the results that we get this discussions, but that we are starting, if we are learning how to exchange ideas, that's the first step. First is establishing communication, and then using the communication to build some models that we can apply to model universe on larger scales. Other comments? But let me maybe stress one more time. The whole challenge with quantum mechanics is observers. Came from of standard quantum mechanics. So there is no problem with using scientific methods and doing calculations if observer is outside to your system. Now, as the moment you put your observer inside of the system and observer observes the universe it's in, that's where all of the problems arise. And one of the problems is the measurement problem in quantum mechanics, and another one is a measure problem in cosmology. And in both cases, it is the presence of observer, like us, the information processing unit that is trying to model and understand how the universe works. So that's the problem. Revel, go ahead.
So are you saying that the observer needs, in order to affect, that needs to be kind of apart from the universe that it's observing in order to have an effect, or not? Can the observer be integrated within the universe and still, work within this context?
Yeah. So look, think about if it's observer who is only observing and doesn't really affecting the universe, it's perfect for physics. So if we have some subsystem, you are from the outside, you kind of look at the system, you do not interfere with it, and then you are in business of modeling. Now in quantum mechanics, it's impossible. You cannot put yourself outside of the system. Measuring the quantum state is interfering with the system, is changing its state. And so that's the problem on the small scale of your local experiment. But this problem is there by default if you are a part of the universe, right? So if you are trying to model the universe that you are part of, all the tools that we previously had disappear, because we want to have some indestructive measurements on the system. So we want to system is there, universe is there, and I'm just observing it. And that doesn't work with quantum mechanics. It doesn't work with cosmology. And maybe the reason for that, my understanding, the reason for that is because it isn't sufficient for you to model the system. You also have to model the observer. Well, neural networks, of course, allows you to do both, right? So you have an observer and a system, and they kind of are interacting with one another.
Okay.
But this is again the problem we discussed earlier. At which level we are we're analyzing our systems. For somehow from your talk, from your words, we can say that probably we are again stuck at the level of the human, and at the level of the human, it's probably more difficult. But on the lower levels, when we would like, if we want to notice quantum-like learning behavior at the level of chemistry or at the level of elementary particles, what are observers at that level who can interfere? If we just want to describe the behavior at this level, what are the observers? Why they interfere if we try to model it at the lower levels?
Yeah. So I think when I'm saying observer, I mean the again some information processing unit that models all levels, or once at least is capable of modeling all levels. We can try to model. We humans can try to model elementary particles, but again, once we model, we have to perform experiments, so we have to interact with them somehow, and then we change their state. Problem. We as humans can also model a bigger system, other humans, and then again, you want to do it indestructively so that you do not interfere with them, but it's impossible because, when you start talking to a person, of course, you're changing the person, you're interfering. And so that problem appears on all scales. It's impossible to hook up a perfect experiment where or very hard at least, to come up with a perfect experiment where you put yourself completely outside of the system. And this problem on all scales. And so maybe the solution is really not to do that, is to model the whole system and then try to model how how parts of the system, which are modeled the same way, interact with the other part of the system. So it's like an information flow. You have the whole universe, and I would say, okay, I'm trying to understand how the universe outside of me works. So I put a boundary. Here's I'm a subsystem, universe is a system, and we are learning each other, right? I'm learning the universe is learning me, and that's how it can. But yeah, the question about inability for us to perform non-destructive measurements, or making it very hard to perform non-destructive measurements, appears on all scales. And I describe only quantum mechanical scales, but the same things appear on all scales. Yeah, that's certainly true. Okay. All right. So this basically wraps up what I had to say about quantum mechanics. As I already mentioned, the same thing, problems with observer appear in cosmology. My guess is really we are at the stage where before it was okay to put out observer outside of the system, but now maybe it's not okay. Okay, so let me enter the second part of our discussion, and then I will want to hear more of your opinions about that. But before we start that, let me just go back to Penrose. So Penrose suggested that the fundamental quantum effects, the quantum effects that happen with elementary particles on the very small scales, he conjectured play an essential role in cognition, right? And the way thought process works. Now, the problem with that is actually well understood by most people, is that every time you have a large system, it's very hard to keep it quantum. It really likes to interact with its environment. Now, in the language of neural network, it likes to learn, it likes to establish connections. And so keeping it isolated is a very hard process. So that's why I don't believe that fundamental quantumness plays a role in the thought process. However, there is this notion of emergent quantumness that can happen on any scale. It can be happening on the scale of fundamental neurons. It can be happening on the scale of the biological neurons. It can be happening on the scale on all other scales. Now, if the learning system figure out that it's advantages to the learning system to use emergent quantumness, then yes, even for the cognitive processes, emergent quantumness on the scale of neurons would emerge. And then you would have, we would say, well, and that's beneficial, of course. We know that for certain computational tasks, quantum processing is beneficial. For example, you are trying to find, a minima of some complicated potential. Now, classical algorithm, you go and you get stuck in some minimum, but in quantum algorithm, you kind of can explore all of the possibilities at the same time. The one good analogy that may help you to understand why quantum computations are beneficial is, again, think about many universes, and on all of those universes there is a computer running, and they're running simultaneously, and they exchange information with one another. So whatever and that's quantum computing basically. And so whenever you start some computational task, you're not just starting it here or in your local universe, but you're starting everywhere. And so that's kind of creates this quantum advantage that would be beneficial for learning. Now, whether this is exactly what human learn to discover by evolution or whatever reason is interesting process. Whether we can set up a learning task and say, well, here it is. This learning task leads to necessity of using quantum computing. And then we can say, all right, so now since the human brains are so good in solving this task, there must be emergent quantumness in it. Okay, so yeah, let me just read the first question and we'll start discussion. The first question was, how do humans acquire language? And what are the cognitive processes involved in language learning? So any thoughts about language? I mean, it's kind of related to what you had before, but still. Any?
It seems that there had to be some kind of an initial start and then a consensus between at least two individuals that would come into an agreement as to a specific meaning regarding, calling this a case for glasses or, but it would start, with more guttural sounds or what have you, and then evolve from there.
All right.
Yeah, I always thought a good model. Sorry if I cut someone off. I'll be quick. I always thought a good model of this was the way that we model, like if we were to contact aliens, like how would you establish a form of communication with them? Like the two models between a neuron talking to another neuron and us reaching out to another civilization, how they develop sort of a language, I've always thought is very similar, like the two problems.
Oh, absolutely, Josh. I mean, this is exactly the discussion we started last time. Again, Revel was not here. You have two neurons. They have not established any means of communication. And so what do, right? It's like two aliens, right? What do? What do they start? Well, I don't know. Just first send a signal. And then if you see that signal comes back, maybe there is somebody there who is but I think here is more about relevant to what Revel said about actually giving meaning to things, right? So I learned something that this is a tree. The other person, I showed him, said, look, it's a tree. Let's call it a tree. And so from now on, we call it a tree, and we do not need to use lots of words to describe it, because, it could have been, this green thing that we saw the other day and was standing right there with all those thousands of leaves, very insufficient. But then we've compressed this whole information and gave it a name, tree, right? And so
I do not agree with that. The first question certainly is not how, but why. And I was not present a week ago, but as well as I understand, there was a big discussion of how, but not of why. And the best theory I heard so far, the answer why is to decrease the level of uncertainty, to learn about the state of other people, and this necessity to decrease uncertainty. It leads to the appearance of some model, and at some point to my model in my mind of others. And at some point, I probably would need to exchange information, to correct my model, to communicate something, or to receive some communications. And out of this arrives the channel and necessity to communicate. This compression thing is probably just something secondary. Probably if our minds were equipped with the direct neuron-to-neuron communication channels, then there will be no language but direct exchange of some neural activations. But we do not have such a system, so we need a system which will do the compression and decompression between our neural networks. So this compression, yes, it's a characteristic of a communication, of a language, not of any communication, but specifically of a language. But it's secondary. But first thing, the first reason is for the communication, for the need of communication, is to make behavior of others predictable, to build a model and to test the model and to understand what others will do, what others have, and what intentions they have, whether to eat me, to kill me, or to go together to hunt with me. But this all falls under the category of decreasing the uncertainty and building more exact models of others.
Victor, but the decreasing of uncertainty and building models of others is exactly compression. So when you said that you want to be able to decide whether the person gonna kill me or give me food or whatever, you've just compressed the enormous amount of information of all photons coming to you and the sounds or whatever into just few words.
No, I agree. I just say that it's the feature. Probably it's not. We can imagine other ways of communication, which probably will be able to directly exchange information without compression. It's the feature arising of the channels available to us. But yes, certainly, as we have only eyes and ears and body parts, and we have to communicate with photons and audio waves. Certainly, compression is necessary. I do not, but to understand how it works, it probably it's necessary to talk about compression. But to understand why it appears, compression is secondary. That's all.
Yeah. So the thing we discussed last time is that there will be even maybe before that is that whenever you're trying to model the universe, there is a lot of information, like you said, photons and sound waves, but a lot of information is irrelevant, and only a small amount of information is relevant for your model. And so putting that filter when you obtain this information and saying, okay, here's irrelevant, I'm just not going to pay attention to that. Like you're driving a car, right? You're not paying attention to lots of things because for that particular task, what's important is the position of other cars. And that's compression of information that comes to you already. And that's what learning does. Also, we discussed the other day is that learning is trying to minimize entropy, like destroy entropy, remove the entropy from the environment and describe it with a fewer beats. Revel, you wanted to add something to this?
Well, so it seems like you're advocating that compression is more advantageous for learning. So the more compression that we can have, is that correct?
No. There is a balance. Of course, anyway, it's not like we are just compressing, right? You want to also to have access to this information fast. Because if you just compress and you want to be able to update it fast, right? So there is, I think this is not a phenomenon that happened hardwired, hard programmed, right? It is just something that emerges, right? So it becomes convenient for you to put a filter. Again, the first discussion.
No, but sorry, but we know now that this compression feature appears before language. The learning of representations. Learning of representations is probably one of the fundamental features of a successful neural network, and it comes before language.
Yeah. So language is what we've decided last time is language is just another level of communication, another complexity level of communication that allows you to compress very difficult concepts. I don't know, quantum physics with 2 words, right? And that is really and right now we're building even another language of communication. We'll say, okay, let's use learning theory to exchange ideas. Again, now we are training ourselves how to take some idea, translate into this language of a learning theory, and communicate it. And that's higher level, but it's built on top of the existing channels, sound and photons. Katya, you raised your hand. I didn't see it. Sorry, go ahead.
I wanted to ask why cognitive processes are in language or linguistic section. Maybe it's related to what Victor said and what you answered. Actually, there are some researchers from Michael Levin, for example, who talks a lot about cognitive processes of some elementary organisms and so things like that. And this is, he calls it cognition. So either what we mean with cognitive processes, or maybe the wider understanding of what is language is meant.
Okay, so I think maybe it's a good point to put here some kind of definition. So for me, cognitive processes consist of 2 parts, right? First, you wanna model the exterior world with something inside of you, right? You want to compress this information, and that you want to describe word with some compact, compressed, an efficient way of describing it. So that's the first part. And the second part is you want to communicate it. Okay, the first part, of course, comes first, and then there is no reason for you to communicate, and we can like build our own theories in our heads and be happy with that. However, if we want to make the phase transition and now we want to be able to exchange those ideas, then we use this models or compressed data in our heads. We use this compressed information to communicate because we found it's useful to represent the world. Let's say using neural networks. So let's just take it as a one cognitive process. You discovered how the neural networks work. You said, okay, well, maybe this is a good way of describing it. And I created in my head a model of it. Now, this is the first step. The second step is to communicating it. And that's where this language part comes in.
I agree with it. I mean that not, as Victor said, maybe if I take it right, what he said, that cognitive processes happens before language as well.
Yeah, no, I hear you. Yeah, I agree.
So, and also it's not necessarily communicating some ideas or concepts. For example, Michael Levin's researches are about some spatial orientation. It's he calls it cognitive process, and probably this is correct. So
here's the one question that kind of relates to what's the relationship between language and thought, right? You can have a thought about the universe, and then you can like secondary express this in certain language and communicate it. And then there was a question about what's the relation between language and reality. So there, this triangle, language, reality, and thought, right?
But do you necessarily need thought for cognitive process? I'm not sure. I'm talking about it. It's maybe.
But maybe even by definition, we can just say cognitive process is a thought of taking some information from the outside world and processing it. So that's kind of what the.
What elementary organisms do, they perform some or metabolic processes. There are some kind of simple tasks. So it is a kind of information processing, but I'm not sure they have thoughts.
No, it's a thought. I mean, it may not be a deep thought. Okay, we're not saying it's a thought, meaning what is a thought? You take information, process it, and you get something out of it. So the compression, the way I would consider it is like compressing the information about your model of the environment. So you have environment, you construct a model of that environment. You do it, I do it, cells do it. Elementary particles do it. They construct a model of the environment, and within that model, they kind of behave. Donald, sorry, I didn't see you. You raised.
Oh, that's fine. I was just thinking about this from when this just started. I came in a little late today, but I just got into this thing here, and one of the things that popped into my head is that as humans, we're not really self-aware until we're like 2 to 3 years old. That's one of the standards, that we don't have self-awareness. That's one of the things that happens. That's about the time that our language really starts to develop. So while we might have thoughts before that, I think as human beings, we're not really aware of our thoughts until we develop a language. So is language more important to how we think?
So let me say self-awareness. I like this, self-awareness. It's related to the universal consciousness that we're going to discuss. Is it your ability to model not only environment, but also yourself?
Yeah, that's what I'm thinking.
Right.
Because I don't know exactly the whole definition.
No,
I just know that I've seen that before.
No, forget about definition. We are making up the rules. We are making up definitions. Okay, so let's have some system that is trying first model the environment, because it has to live in this environment, survive in this environment. And so the first cognitive process is modeling, like you said, in the first 2 years of life, is to understand what's going on, who is dangerous, who is not, and after that, once you already have a good model, pretty good predictable model of the environment, then you start asking deeper questions. Say, well, maybe I live in this environment. If I learn better who am I and how I function, maybe this will enable me even further to model the environment. And so you discover that it is beneficial for you to model yourself as well. But I think the language can appear on both scales. It can appear in the beginning where you're just modeling the environment. You have a twin brother, and you're saying, well, look, or, you show something or smile. I mean, right? You don't have awareness about yourself, but you already have a language of communicating. Like smile, right? It's a language. It's a certain way for you to transform information from one information processing unit to another. So I think it is important that we become self-aware later on, because it's not for you. It's important. It's not as important in the beginning, but languages are there all the time. It is only the complexity of languages that changes, and for kids as they grow, and for the civilization as it grows, right? So there was no language of mathematics 6,000 years ago, and here we are. We think this is the way to describe phenomena around it. Revel, I think you wanted to say something.
Well, it just has occurred to me that language seems to be a rather inefficient means of transferring information, and compared to a visual, for example.
Well, it's more efficient than visual. By visual channels, we receive a lot of information, and most of it is irrelevant. It's a lot of photons are hitting you every split second, and then yet it is only certain patterns in those visual activities that trigger anything at all in your brain activity and make you actually use it. But language is actually very compressed. As I said, I gave an example: quantum mechanics, right? 2 words. But those who know, it's I don't know, 3 books of the material. Katya, go ahead. You wanted to add something.
Yeah, I want to ask again: do we call language any kind of information exchange, or if yes, then visual representation is just some form of language? No,
I think it is. And again, it's just like with the what's life, what's not life, right? It's hard to put a border, a boundary. Now there is something that we can decide to call language, any means of communication, and then something that people call language, where this is means of communication that were agreed on by the people who decide what language.
Yeah, but what do we decide to?
I think a layer. I think it's just going to be layers of complexity, right? So, and then I would say there is a least complex level for us, for humans, maybe visual. Maybe then sound comes. Then there are another. Art will be very high in the hierarchy. You cannot appreciate art until you are much older, I guess. Or
I want to say the difficulty I have with what you said. So you could say quantum mechanics, and that will summarize all that. But then this encompasses so much information that almost nobody could comprehend all of it. Like Richard Feynman said, if you think you understand quantum mechanics, you don't.
That's the whole point, right? That's the whole point. So even when I say quantum mechanics, I really mean not only understanding it, but understanding that you don't understand it. So it's really it's many you have to learn mathematics, then some more basic physics, then quantum mechanics, and then you will eventually understand what this term means. Before that, it's something that you only vaguely know about, maybe from some popular books or so. But it is a compression of deeper and deeper ideas. And the reason we have that is because otherwise we wouldn't be able to communicate all this information. There might be other channels that we just haven't explored yet. Art is one of those things that we'll be discussing. Some people are able to communicate through art, or establish language channels of communication. There's one is communicate, and the other established language of communication. So maybe people who have the same sense of humor, they may have an easier time to agree with one another. And so first they joke around, and when people meet, and then they eventually start talking and discussing some deep thoughts. So then it's important. And then back to Katya's question, yeah, it is just the matter of how we decide to call it. I would just call there are different layers, like the levels. Sorry, there are different levels of languages, just like there are different levels of organisms. And one has to do with nodes in the context of the neural network picture, and the other one has to do with the weights, connections, or edges in context of the neural network picture. And both have to grow, right? So, for example, if we were not able to establish language communication and we were just showing signs and making sounds, we would not be able to create computers have Zoom chat, for example, because language was important. The English language and language of mathematics was important for us to make progress. And so those new layers of complexity are important for the phase transitions to take place. Yes.
So it comes out that we call language a way of compressing information, right?
Two things: channel and compression, right? So establishing new channels and then the way of compressing it, and the same with the channel, right?
What's this channel?
So for now, we just use very simple channels, right? So we have built our language on top of the simple channel of communication, which is the current goes, so using electrons as the current goes to your computer, and then light as it comes from your screen to your eyes. So those are the channels of communications. And then there is
probably the most important thing are two sides. The channel is defined if there are two sides to the communication. So if, for example, we see some patterns in the sky, and we try to interpret these, or it's not a language because we are not communicating with anyone. We are just receiving some noise or probably some divine communication and interpreting it without other sides. So
okay,
the language requires two sides for the communication.
Yeah, so that's a good point. Now we can have communication between different levels in a hierarchy. So we can have an object consist of only atoms without living cells communicating with us, an organism consisting of many cells. And now we have physical object communicating with a biological object on the higher level. But that's all communication channel. And maybe we shouldn't call it language because it's from lower level to higher level communication. And that's when you're saying that you see something in the sky. Well, I mean, it is a communication channel, right? So you obtain it. It's maybe not very advanced one, and there is only some frequency of photons that you can easily get some spectrum, analyze it. By the way, we are not even actually using all of the channels for the photon communications, right? A very narrow band that we decided to use. We just said, and then that makes sense. We cannot use too much, because if you use too much, then where are you going to store all this information? So we decided to use very narrow band for our communications, and other animals chose slightly different band, and they're just fine. Donald, go ahead.
Yeah, I think to Revel's question, I think I kind of look at it as that if you're standing out in a field just talking, you're not really communicating. You're broadcasting, but you're not communicating until there's somebody hears you. That's your channel, is the line between you and the receptor.
That's actually a great topic, because there is a difference between broadcasting and receiving. So you can broadcast information, you can receive information, but you can also generate new information, so on all levels, right? So for example, you can I heard some good idea, I'm going to tell you. So I'm like rebroadcasting it. Or I'm listening to everybody who is saying, I'm receiving. But there is this third and very rare event where some new idea comes in, maybe simultaneously for different people, for different agents, and that new idea is being broadcasted. So those are the three different things. Yes, I agree.
Vitaly, what you are saying is basically that any measurement really requires language. It's connected with the measurement problem then.
It is communication. Well, I mean, it has completely connected with the measurement problem in quantum mechanics because it's getting information about some subsystem. Absolutely. But
Victor,
sorry, Josh, I'll give you just one minute. It's all about two types of two ingredients that we have: nodes and connections, right? And they're directed connections, as Donald pointed out. Yes, and it's all about that. Josh, go ahead now.
I was going to say, in Victor's scenario, where you're looking up at the birds in the sky and not really communicating with anyone, I'd actually say that on a general level, you are. It's the environment is doing the communication, and the language it's talking to you in physics or whatever. And I'd also say that language, as far as like how to think about it, I guess one thing that's helped me to, and I don't know if this is accurate, so I'm going to think about it some more, is to think about language as an API, because we're all pretty much familiar with APIs. Or maybe we're not, and so maybe it doesn't help to think about it that way. But APIs can exist between different systems on different levels, and then the APIs can grow or they can shrink, and they compress information or they translate information. So but it's all kind of grows with the organism. So I kind of think that's an interesting way to think about language, is to model as an API, at least in my mind.
No, I think that's pretty good. Not only it grows, but also it increases complexity, because growing is also discussed something last time. We can have communities that have different languages, and then they come into contact. The first thing, they establish a dictionary, which only works on the intersection. Then they start borrowing terms from each other, and then it becomes a union. Okay, and for now, no new concept had been formed, and so no complexity to this language was formed. And then eventually the system becomes enough complex, and then the new level appears. And so now it's not just talking, maybe writing formulas or writing theories, and then all of a sudden higher and higher complexity structures within the language start forming. But again, I mean, we can put a cutoff and say like everything that doesn't have to do with communication and that can be written using English words, we do not consider language, and that's fine. We can do that. We can just put the cutoff. We'll cut off a lot of small-scale communications. A lot of art will be cut off, by the way. So a lot of patterns that we think are beneficial for us will be cut off unless we give them a term. Let's say that's how we're going to call it. That's fine as well. But I think that in a more general case, like maybe let's say generalized language, it just all means of communications, and more precise language is of course what we speak or what we can write. Chat. Other thoughts, ideas before we start a very speculative subject? And unless you guys ready, okay. Well, now imagine before we go to that. So it's universal consciousness. Right, so we were talking about language, means of communication, and there was always this environment and other agents. But now let's say that before we go to the universal, let's say there is nothing like that. So you just close your eyes, you're in a coma, right? So you are not able to react to anything outside. However, you do have some thoughts. Now, do you call it consciousness?
I'm not sure in coma you have some thoughts.
Well, no, there is a processing, right? Information, I mean, dreams, right? Whatever. I mean, you have something, but there is no means for you to interact with the environment. You are not seeing anything. It doesn't affect your. So if you are so lonely, would you consider the system conscious, or we do need environment for something to be conscious?
No, but it essentially depends on whether you had previous experience of environment. If
let's say you imagine the previous experience of the environment, it doesn't.
No, there's no difference. If I remember something, and if I remember some prior communications with environment, if I somehow acquire these ideas of other points in other spaceships, then it's consciousness.
Okay, so yeah,
probably the question is where I had acquired this idea in the first place. But if I somehow acquired this idea and performed some experiments before I was just cut from other spaceships, then
No, but the question is asked. I'm asking you this question. You're asking yourself this question when you are already cut out of the communication. So you can say, well, maybe I'm hallucinating, and I have really never had any such. You're Boltzmann brain. So basically, you have some thoughts. You're floating around, but there is nothing there. It's darkness. Complete darkness.
The only answer I know is what's the difference.
There's no difference, and so then there is no difference for you whether you had a previous experience or you were just hallucinating having previous.
No, I mean, what's the difference for me? The difference is for the person who is responsible for turning off life supporting equipment for the person in a coma. That's the problem for such a person who can turn it off. But it's not a problem for the person in the coma.
Oh, no. The question is not about the problem, but whether you are considering yourself to being conscious, having a conscious.
In coma, you are not self-aware. So how you can consider anything?
You're a Boltzmann brain. You're a Boltzmann brain. You have all of the thoughts of being conscious. Just all of a sudden, you just lost. Right now, we'll just close your eyes.
Are you sure you want to talk about coma, not about sensual deprivation, for example? I don't understand this example with coma.
This example is whether we should consider an isolated system with no contact with the environment, which is capable of producing thoughts.
Sensual deprivation is
not possible.
But in this case, you have some signal. You can still have some signals from your body. I mean, some internal.
Yes, you have signals only from your body, but nothing outside of it. I would call it a conscious system. So I would call it a conscious system that is not capable of establishing new connections with the environment. And so.
Okay. Yes, I agree.
Yeah. Okay.
Yeah, but what is principle is in this state you are self-aware. You know you exist.
I don't know what self-aware is. I don't even know if I exist, but this is a conscious experience. I think I just wanted to get our terms straight. So you have a consciousness, right, at this state. Because when we move to universal consciousness, I think it is like that. We have a system. We have a very large system that is, has nothing outside of it. It's the universe, right? And it is it has some thoughts. We are thoughts. We are part of those thoughts. Now we can ask the question whether this universal system is consciousness of us, which was the first question. Whether it's conscious of itself. So like it's asking whether it's conscious of us. It's asking whether it's conscious of cells. Let's say, right? Is it conscious of that it's built out of cells? Presumably, it can think long enough and figure out, well, probably, there are cells that it seems like a good model and so in this case, potentially, it can become conscious of us if we are like cells of that, hypothetical Gedanken experiment we started with. I'm not sure that had already happened. And I'm not sure what this universal consciousness system can do if it does figure out that it is that we are there. But anyways, your thoughts. This is just the first question. We live in a neural network. That's what I just described, right? No environment. This whole neural network. Is this neural network, this huge, humongous system, aware of us, where we are just sub-networks? What are your thoughts?
What is most interesting? Yes. That we are not simply cells, we are not epithelia, we are neurons of this big system, and that's most interesting thing.
Well,
not any cells.
So I just moved this complexity level a bit up, right? I think the still question is there. Now, what you said that we are not just cells, meaning that our cells are capable of a lot more information processing than the cells that make of us. This makes us different, but there is another problem. We are not as collaborative as cells in our body. And so this is the second aspect when we are different, because the cells in our body are already decided to collaborate. They're already formed, structure.
Yes, but we discussed that some weeks ago. whether our Turing completeness, or not so completeness, but where our computation, where the past like some computational barrier, and it became theoretically possible for us at least potentially to understand whether the universe is conscious or not. And probably at some level below, our cells are not capable to understand, to comprehend our existence or universe existence without passing this computational barrier.
But that's what Donald said. Even babies are not self-aware, right? So it's not just being complex.
I'm not so sure about these results which you quoted, really.
So you think the babies are already self-aware, right?
Yes, I rather say yes.
Okay. Well, at least it makes sense.
Maybe a tiny bit.
Tiny
Not,
awareness.
but
So I mean, yeah, it's not a sharp process. Like you are not aware now,
Yeah.
you're aware. I think but it makes, from the point of view of learning theory, it makes theory for first to figure out what the heck is this environment, right? You know, how to deal with everything without around there. Once you have a model of the environment, then you can gradually say, okay, here I am, and I actually can change that environment by doing such and such things. And maybe that's what we call self-awareness, when you are actually capable of modifying what you see and what you observe by doing certain things by yourself. Okay, Josh?
Yeah, I would say for everything I've seen, it seems like the universe is going to be self-aware. But as far as its, I mean, if you look at its age, it's like fraction of a second old. And I watched a simulation of how long the universe will last, and basically like nothing's happened yet. Like everything is still yet to happen, and that makes me think that there could definitely be a process that happens in that huge span of time where the universe becomes self-aware of itself, much like the human species became self-aware, or much like a baby becomes self-aware. I think there's a similar process that's going to unfold on the universal scale. Although that's basically from reading papers from this group.
Yeah. Okay. So I think actually I agree with this. I don't think that we have made that phase transition when universe becomes as a unity self-aware. It is just two disjoint. We just have lots of self-aware parts of it that hadn't been combined together. Well, at least here. I mean, maybe some aliens already made this phase transition and they've joined their themselves in like more coherent structure, and maybe that structure is self-aware. Actually, that explains why we never observe aliens, because they just already went through the phase transition of stop being aliens but becoming the super intelligent thing that is self-aware of itself and then looks at us as stupid cells and then stupid primitive algorithms that haven't figured out how to create multi-human organisms. Skynet. Yeah,
I had tried to build the spectrum of what systems we are ready to believe are self-aware. The humans is the most obvious thing. Next, I think we are ready to believe that animals, products of biological evolution, built from basically the same cells, the same type of cells. Probably we are ready to recognize them as self-aware. The next will be probably alliance, products of the biological evolution, but not of some other type. Only after that come our own artificial creations. So we will be less inclined to believe that they are self-aware. And if we try to put the whole universe on this scale, I think probably we will be able to believe the self-aware even earlier than we believe that our own our own artificial creations are self-aware. So it's not it's really a question of belief, really. And we are
I think it's more than that. I think if we model the universe as we model it now, then really different planets, different stars, different galaxies are not collaborating in any smart way of producing any deep thoughts. And so with this model, this whole thing is not self-aware and nor consciousness. Now, if we are to modify this model and then all of a sudden create another model where there's, those larger structures have already formed collaborations and underwent the phase transition that I keep talking about, then yeah, but then we would have to modify our model. With current model, it seems like the universe is pretty stupid and doesn't have any coherent thoughts. So
No, I really like to read what Stephen Wolfram is writing about this. He is trying to imagine what will be the differences in thinking processes of the entities which are sufficiently different from us in their scale, in the speeds of their processes. And he brings exactly the same example. Can we imagine the thought of planetary or galaxy-sized consciousness? And so probably it will be just incomprehensible for us. Other types, our types of laws of universe will be observed by such entities.
So my professor at university a long time ago did a thought experiment where he's like, try to imagine like another form of consciousness. You really can't do it, but then he kind of stepped through a process where maybe you can kind of imagine it. So in the way sort of was like, imagine an internet where you stepped into it, where every human that was in this internet could experience every other human's experience. So just a thought experiment, experiment. It doesn't exist, but just put yourself in this mindset where you hop into this computer box and allow anyone else that's in that box with you in that virtual box, you can experience everything they're experienced at, maybe you hop through it or maybe it iterates through, I don't know. But he's like, you can imagine how more and more people would join that box. The box would grow and grow and grow. And the consciousness that box makes up would be like qualitatively different than your consciousness, but you can't really explain how, you just know. And that's what you kind of imagined a super consciousness would be. And so that kind of thought experiment is what I do to imagine perhaps what higher consciousness could be. It's like this super collaboration, not only in communication, but also in experiences. And why I think this is important, because it also explains how you could grow into a super consciousness, because at that point, you're just dealing with what's called network effects, where there's some benefit to being a node inside the box that you don't get to being a node outside the box. And because suddenly you have this growth, you have the model for growth of the super intelligence. So I just thought I'd throw that out there.
No, but this is how our community grows, right? This is exactly what we want, because we get a new experience by being a part of, and any community would grow this way. So, but I think the one important point that is, if that happens with all civilizations out there, and they eventually merge in this super consciousness, then they stop functioning as individuals, as a separate, human aliens, right? And that's why we wouldn't see them, because they would just not be that. It's not beneficial to be that way. They just all merge into one thinking unit, whatever. Katya, sorry.
I want to.
I'd like to address the concepts of some spiritual teachings here. I'm not sure we can map it somehow here, but I can actually, it's difficult for me to think of universal consciousness without addressing it. So the idea is that the universe or universal consciousness or universal mind or God is trying to attain some self-awareness through us, through our experiences. And so we are kind of like some kind of sensory organs, because otherwise it cannot know about its own existence. Can we somehow...
But Katya, one question, is that thing that you described outside of the system and it only receives information from us as sensors, or is that thing is a part of the universe? Those are two different things. So if it is just receives information through us, then it is like an observer, super observer.
No, I would say it's a part.
If it is a part of us, then it's really, it's not up to that super consciousness or whatever you want to call it It's not up to it to figure out how to use us. It is just a part of the evolution of that universal neural network, right? It's not like, okay, I decide to use Katya as one of the sensors, Vitaly as the other sensor. No, this is not the free will. So
well, the idea is a bit, I don't know how exactly to answer if it is inside or outside. The idea is that it creates some.
Okay. So let me comment on that. Now, then think about all of us as just what you described, that thing that is trying to. But and then we just haven't collaborated yet enough, so we haven't merged into one thinking. That this universal consciousness haven't emerged yet, and once it emerges, then here it is. Once we all start functioning as one thinking system, here it is. Now God had been created.
That point, it was already mentioned by you and by Josh, but I don't. I'm trying to understand what it means. We are talking about some phase transition here, but it's a phase I don't transition. Quite understand what is meant. Can you?
Sure. So let's go back to the unicellular algorithm phase transition to form a multicellular organism, right? So you had individual cells, they all kind of were doing the very same thing, and there were no difference between them. And then they figure out, these cells are better in doing thinking process. These cells are better in transmitting information. So this is like those will be longer. This will be will form more complex networks. And then the roles were redistributed between them. And then they no longer are able to function on their selves. They've merged, right? So each individual cell is no longer able to be a unicellular organism. Its ability is gone. And when it's gone, this overall thing can process information much better. It can memorize things a lot more, be self-aware, and doing all of the things. But at the same time, it doesn't function as parts. So
are there any ways for these single cells to understand that this happened? Can we really imagine any manifestation which will show us that, again, yes, it's true, the universe is conscious, so it has achieved consciousness. Can we imagine in any way how we will get this information?
So that's what I'm trying to explain.
Yes.
So we individually have consciousness. We haven't merged into one common thing, right? And so that's why this common thing is not self-aware of itself. When we do that,
what if it's a filter problem?
Say it again.
What if the universal consciousness is there, but the resistance is the problem is the individual cell or the filter over the individual that is blocking us from that?
It could be, right. So maybe there is already some kind of self-awareness. So, okay, let me just put another hypothesis here. Some channels of communication between different nodes had already been established. And so there is some notion of collaboration is already there. Now, not complete, as we are still, functioning very much selfishly most of the time, but there is some communication, some channels of communication, which isn't the channel of communication that we are using. So it's not maybe three-dimensional lights and sound, but something else. If that is the case, and so there is already this connectedness between us, then I would say that yes, this whole thing can have consciousness. If there are some other channels of communications that allow us to assign roles, let's put it this way. Now, if there is none, then I don't think this phase transition took place. So it's all phase transition.
Sorry, the distinction is not whether there are channels. Distinction is whether there are channels which you cannot avoid. If we are included,
You're right.
And you know that there are many who believe that such things appeared already, nations, states, etc. And there are people who think that you cannot avoid being part of a nation or part of a state. That there are channels which govern you, where you are a part, and you cannot avoid being a part of them.
It's beneficial
unless you block them.
It is much more beneficial for you to be part of it, using this communication
So,
channel.
but you are programmed. I think it's a problematic idea of this separation. We can perceive ourselves like some separate elements, but is it to what extent it is true? Because we are not actually. We are programmed by culture, so our thoughts are not ours. So.
Well, our thoughts are ours, but based on the knowledge we received as we were growing, right? On this information, they are constrained, very much constrained thoughts. But I think my point is that right now the information that flows through communication channels is much smaller than information that we have inside us. Like we have a lot more processing inside of our thoughts, and very few bits of information actually sent across internet. And so right now we are mostly selfish people who are kind of optimizing ourselves rather than being part of this
for sure
bigger thing.
But what about education? Any human is programmed during the growing up process and education, and so if you just put some baby in the jungle, suppose he survives, but he won't be what we call a human being.
That's
So,
right.
Tarzan.
He will be missing lots of channels of communication. He will have other channels of communications, but what I'm saying, I think you need a lot more communication.
yeah, I mean, so this being social human being, it is programmed by the society,
by the rules of the society, yes.
So
which
can we really talk of this like it is separated? It is separated. No, it is completely mount in this system.
Yeah, but we can easily break off, right? I mean, you're part of one society where you grew up. You can move to the other society, or you can go to the some island and live there. I mean, you are not really. You can survive without the society. It may put some discomfort into your everyday life, but you can do that. And so that means that you are by yourself. You're mostly by yourself, and this societal structure was just imposed on you like a few thousand years ago, and then it need not be there. But I think if there will be more interconnectedness, if there would be this phase transition where we just cannot survive without each other. Secret channels of communication, Richard. Go ahead, Kathy. Sorry.
And then in some ancient societies where people actually could not survive without the others.
But they were small societies, very small.
Yeah, but in this case, so should we consider this phenomena as they were one organism?
Yeah, so this is a prerequisite for this making this bigger transition of making everybody join one, thinking super intelligent system. Yes, so this is the way transition takes place. The bubbles are boiling. They start boiling and then they shrink. It's like
one quick thing.
Bubble expands and then shrinks, and then eventually everything starts boiling, and then everything turns into the gas. So you're just telling me that here and there were attempts, and we're still having this attempts.
So are you saying that at that point of time it was there was more interconnectedness between the people than now, and it was closer to then how we
at
should.
what time?
Well, amongst that small group is the point. It's a small localized,
Yeah. But still, answer the question, Katya. Do people in that small group had more thoughts within themselves, or was there more information exchange between them? And my argument will be that there was a lot more thought going on inside of each one of them without them being actually able to express it. or know enough languages.
What period of time
That's
are
as
we
it should
referring
be.
to here?
Or
What period of
Don, sorry,
time?
go ahead, Don, go ahead.
I think a big part of this is we're losing sight a little bit of the fact that you keep going towards this phase transition where everybody's going to be on the same conscious level.
Mhm.
But look within your own body. Your whole body is a grouping of cells that are all operating together to keep you in one piece, but they're all doing their own thing for the most part.
That's right.
And then they send a signal once in a while to the brain interprets some stuff and tells somebody else to help out with this or not do that. So like there's a lot of independence going on within the individual cells throughout your body. So we could be here doing our own independent thing in the greater consciousness of a conscious universe.
Exactly.
And for some
Yes,
reason, we're
yes.
doing our thing that's important to it. We don't know why, but our rules of life and survival are congruent with, our survival and evolution is kind of like, that's the reception we're getting back to some higher consciousness.
Okay, but again, is this high consciousness within our three-dimensional space-time? If it is, then current model of the universe doesn't make it very, very smart, right? Now, if this consciousness is just outside of the universe and yet it just uses us as, maybe just run some tests, like do computer simulation. Let's figure out how things work.
Right.
But try a few things. Now,
but a cell within your body knows what it knows. It could do some tests within its knowledge and still not know what's going on throughout the rest, whether it's inside or outside. Yeah. Because our frame of reference is limited. Right. In our knowledge base.
Yeah. So then it would seem that greater consciousness does have a lot of hopes for us and does want us to become smarter. And does want us to make a phase transition to be actually smarter as our small local group of cells. Victor,
right.
you had.
I would like to see to do some probably simpler job. Just start from the collecting evidence that there are signs of consciousness at a higher level than a human individual, and probably it's possible to start collecting the evidence starting from the level of the family, of a nation, of a state, humankind, and then move to understand whether there are signs of consciousness at cosmological level. But the really one question is for the theoretical point of view about phase transition is whether we should expect the phase transition going by these system levels. Should we expect that at the level of humankind, the phase transition should become earlier than at the level of the solar system, or it's not necessary, and probably the phase transition will come at the cosmological level without coming at the level of the humanity before. What's the theoretical? What the theory says about the phase transitions at different levels coming out of order?
Yeah, so what we see is that it's from down up goes. So first the smaller scales start collecting, but technically there is no problem, right? So if some phase transition happens with larger systems, and then first, and then with the smaller systems next, I don't think there is any problem. I don't think we've seen evidences for that. But one thing I should emphasize that what the theory tells us, there is going to be a hierarchy of phase transition. It's like ongoing. It's like system is always in a critical state, and those phase transitions are just happen one after another, and then that's what's. Go ahead, Katya.
Another thing, on one of the previous meetings, I think we defined consciousness as the efficiency of learning. So how can we link it here?
Right, so that's why I kept saying that universal consciousness is not there yet. It's not self-aware, because I do not see it's doing anything efficient on that scale. That's why I'm refuting this idea. So we have to change the model. However,
so
there are things like dark matter, dark energy, a bunch of stuff on this large scale that we haven't explained. And so once we see a phenomenon that shows that there is some kind of very efficient way of doing things on larger scale, then we can say, yeah, okay, here it is.
Yeah, but I mean, when we are talking about what is consciousness still, if we are talking about human consciousness, what do you mean? I think through this conversation, we mean something like self-awareness, or
well, I think self-awareness is just part of it. Again, like going back to what Donald said, and maybe in the beginning, children are not putting too much effort into trying to learn much about themselves and more about the environment. It makes total sense. First figure out where you are, and then start questioning, what this hands or arms, whatever, have to do, and how I can benefit from that. So it is all, I think it's just part of it, self-aware, and the consciousness is still, I would still equate it to the efficiency of learning, like you said. And so the more efficient learner you are, or any subsystem, the more conscious, isn't it? Because it's capable of modeling everything around it much more efficiently, faster. That's why I'm doubtful about the universe as a whole being very efficient, but some of its parts are very, very efficient learners. Rebel, go ahead.
At what point did you become convinced with your model that this has been attained or partially attained? And what signs, or what would you receive?
Right. So changing the model of gravitational physics, for example. So if we are talking about modeling the entire universe as a learning system, now figuring out where the dark matter, dark energy comes from, and whether they are really indicating and showing that their learning algorithm is better than what it was before that. And so if I see that, then I would be more, and again, I mean, I'm just not dismissing this at all. I'm just, as of now, on those large scales, gravitational scales, I don't see any efficient, like say quantum mechanics. So quantum mechanics is very efficient algorithms of learning, it turns out, because it removes neurons, puts them back, as we discussed earlier. And so as the learning system figure out more and more effective and efficient algorithms, we should see signs of it. We do see signs of it in biology. Like all of the biology is built out of this small algorithms, like program death, that are very, very efficient. And how it was discovered, we don't know exactly. But it as an algorithm, it functions very efficiently as a learner. And maybe this why I'm so much interested in this phase transition, because if we are actually capable of creating as human race size intelligence, then it's already evidence that we as a parts were good building blocks for that. And that would be evidence saying that maybe we are part of this, super intelligence. But on the gravitational scale, I just don't see it yet. That's why I'm saying. I'm
still trying to link a few things. So this definition that consciousness is efficiency of learning, how we can use it talking about, for example, first question in the universal consciousness section is it conscious of us? So conscious, what does it?
Yeah, no. A good question, right? So I think before it can become conscious of us, there are 3 steps, right? Again, going back to what Donald said. First, you want to be conscious of the environment, learn the environment very fast and more efficiently, and make sense of the changing environment. Second, you want to become self-aware of yourself and start modeling yourself. When you do that, you start becoming conscious of parts of you, of your cells, right? And then in this example, you would be conscious of us. The universal consciousness would be conscious of us. Now, since for the universal consciousness, there is no environment, it's all there is. So the first problem is solved right away. It's not there, non-existent problem. The only thing it can do, it can start actually thinking and modeling itself, like a Boltzmann brain in the universe that sees nothing and just hallucinating stuff. If it's capable of start coming up with some model of itself, then it's self-aware, of course.
Yeah, I mean that. This previous definition, it's not quite correct to define consciousness as just efficiency of learning, because it's not all. The definition is actually more complicated. So it's
maybe more
Katya,
complicated.
we're equating modeling with it's important point. We have to probably tell it explicitly that we're equating modeling with learning. Learning is building of a model, and if that's an assumption, then everything becomes clear. But then the problem with the universe comes from the other side. The universe cannot build. The model is always simplification, and if universe is starting to model itself, then the question is whether it's possible for it to simplify its own model. If it contains everything, then where is the simplified model? We can imagine simplified model of our bodies. It's not a contradiction, but simplification, building of some internal representation of everything for everything. That's really the problem, which requires some further.
Hold on, I don't quite follow. If the universe with nothing outside starts modeling itself and saying, okay, here's a part of me where I'll be recording everything, a small version of this entire universe. I'll be just recording it here on Earth. I'll be creating a model of everything. Then it's okay. It's did exactly what it was asked to do. It's used some of its resources to come up with a simple Occam razor's simple model of the whole thing. There's no
looks very recursive to me, but I have to think.
No, but again, you're always doing that, right? So right now, when we are having a model of how human body works, what do we mean by this? It means, and we store it in our brain, right? What do it mean? It means we just
the model which is stored in our brain is not a very good model. Much better models are stored in the books and computers.
No. Let's imagine them when you take all of the books and you put it also in your brain. I mean, there is enough resources for that. Now it's not a very good because there's a lot of books that are not worth putting there. But if we just concentrate on the good books or good equations, good models, then it's usually a very compact thing you can write, and then it would be stored in part of you, and it would describe how you think. Again, remember that equations that describe some dynamics are much shorter than the state that these equations can produce. So if the universe is able to write some place in it, a standard model, general relativity, quantum mechanics, that's already pretty good universe, and pretty smart universe, and it would be self-aware in the sense that he has a very good model of itself. I'm not sure that what the universe did. Some of its parts did exactly that. We did exactly that. But did the universe do that before us? That I'm doubtful about, and I don't know. So, and if it did, then we should see evidences for that, for the universe being so smart and being able to do this compression of the laws of the universe itself. I don't know.
Is that why we're here? Specifically, this group. Are we the first steps?
Well, okay. So
figuring itself out.
Yeah. So I think that this is what we want to do, right? So we are just saying that individually, we are very good in doing certain things, but we are very horrible in communicating ideas to one another. It's true. It's a matter of fact. People do not know how to communicate ideas, and this. And so if we can establish that maybe we'll be capable of producing that universal consciousness, at least, well, maybe not universal, Earth-like consciousness. How is that? I mean, that would be good enough for me. Other comments? And we also have to make use of the AI consciousness, right? So because we want to get plugged into that and make use of their ability to memorize, because AI systems are very good in memorizing things, not very good in creating new things, and that's maybe a good collaboration. Other thoughts, ideas?
When you are talking about us being conscious about the activity of our cells and so on, of our bodies, again, maybe it's problem with terminology, but I wouldn't say we are conscious of that. It functions somehow, but we don't have control, or we don't.
But that's why I'm saying we are, as a group, have very low consciousness as a group, because we are not functioning as a united network of interconnected nodes, which is efficient learner. We are separately very, very good learners. You know, each of us figured out how to live in this universe, how to, walk, how to talk, which is very complex thing, right? But as a group, we are not adding anything. All of the societies, communities are not adding much to this overall consciousness.
But what is the connection? If we are talking about the human body, it functions, all the cells or bacteria or whatever, they are functioning quite well. So yes. I was saying that we, as a human being, I'm not conscious of what is going on and how it works, and I don't help it somehow. So it functions.
No, you cannot help it, but you're conscious of it.
In which way?
Well, you're conscious of what you're made of, right? You have a self-awareness. You're conscious of that you are made out of cells.
But you cannot. But there are very few people who can control their autonomic nervous system.
Exactly.
So
you cannot really control it. But you're conscious of it. But as a group, we are not very conscious because we are not adding much to the consciousness of individuals, right?
Because you don't have to control the body because of the independent nature. There's certain rules are set out there, and the people do what the cells do what the cells do. Just as in society, people do what people do. You have a base set of rules. You don't need that level of communication, because that level of communication in some ways will introduce an inefficiency.
Yeah,
although there are examples of, I gave an example that's extreme weather athlete Wim Hof, who could control his autonomic nervous system under the auspices of a doctor, could be injected with poison and just turn it off so it would not have no effect on him. And in terms of having these abilities, might be advantageous, or to be able to withstand, extreme temperatures. And somehow these super control features.
Yeah, there are some super abilities. Some yogis can control what is going on in their bodies. That's one thing. But what I'm talking about is that a normal average person is not aware of what's going on. And can we just about the say that we are conscious of what is going on? I think
we are conscious. We are conscious, but not self-conscious. There you can see in the brain activity, you can distinguish the patterns which are governing all these functions, starting from heart being. And in essence, it is not different from the neural mechanics which governs your communication, your speech. And so that just means that there are many different types of attention in the brain, and some of these attention heads are governing, are really connected to this external communication system, and some are not. But neural network and the principles of learning are probably the same as biology for all neurons in all parts of our body are the same. So it's not a good distinction really. We are not self-conscious of many of our internal processes, but they are still conscious. Our brain has the model of our whole body, and it is processing signals and giving commands just in the same way. It's governing our communication.
It is just some degrees of freedom are very well trained. They don't need to be touched and changed. And so those are the degrees of freedom that are still working. Now, yes, yogas can say, all right, I want to change some of this as well, but it's not necessary, right? And then there are other degrees of freedom that we control a lot more. we can move hands, look in different
As
directions.
as an analogy, my cousin suffered a stroke when he was early middle-aged.
Mhm.
And the lingering thing that he has with it, he cannot process conversations. He cannot distinguish conversation. So think of being in a crowded auditorium where thousands of people are talking. He doesn't know which one's talking to him. He hears all the conversations equally. He cannot distinguish that is you and him are having a conversation. He hears everybody at the same level and cannot filter it out.
Yeah,
Whereas we
filtering, right.
filter a lot, and that's what we do with our body. There's a lot of stuff going on that our conscious mind just says, this is extraneous noise. We don't need it because it's running fine.
Right.
So unless there's some kind of built-in, alarm bell goes off, we ignore it and it runs. And it's the same on pretty much any system level. Once you get above a certain level of complication, you have to filter down and only listen to the signals that are important. Because if you listen to all the signals equally, the whole system's just going to break down.
Okay, that's a very good point, because we as a group or a society are not able to do that. We are not able to efficiently filter irrelevant, theories, ideas, and concentrate on relevant theories, ideas. We are very inefficient in redistributing roles.
But before you even go there, don't you have to define what's relevant and what's not? What's most important about? So, you can talk about efficiency of learning and this is the best thing, but what about love and intuition and this other,
figuring out what is relevant and what's not relevant is again, how do we
as a species, right.
Yeah. So I think that we got to use scientific method. That's what I propose. Other people say that they just want to, believe in something, right? It fits better with their theories. For me, it has to be scientific method. So if we have two competing ideas, we'll go on, conduct an experiment and decide who is right. Okay, and we'll be redoing those, and we are not going to be dismissing ideas just because they're not popular. Or other ways, we're not going to be rewarding ideas that are popular. We're just going to be using the actual experiment there. And that's how we work, right? We do not dismiss ideas just because we don't like how they sound, as long as they are okay with modeling the environment, right?
I don't know if I totally agree with that, but I do think even as science and engineering and that, there are times when we dismiss certain things. We rule them as unimportant for this.
No. We
don't take everything into account.
That's filtering.
Yes.
That's filtering.
That's
filtering. We absolutely must do that, but we must do that on the level not of individuals, of the whole system. Like, for example, you're going to be filtering information about general relativity because for your task it's not important. Now the other person who is designing satellite, they would be including the terms that have to do with general relativity, etc. Right? So it is, and it happens with our body as well, right? So our eyes are very sensitive to light, and not so much all other cells. They are filtering that information, and that's okay as long as we as a community we know who is filtering what and why.
There are many things we can learn to use as a community from what we know now about the functioning of a human or from an artificial neural network.
That's right.
For example, like things about with attention. Yeah, we have to fix. We have to leave some trail of what we are doing as a community. Each company knows it, that you have to, at some point you have to put on paper what is going on. You have to put trace. And you have to, you need an ability to focus on something. You have to return to things you have written and discuss them again, and then leave them for some time and come back to them without losing the information. So these are things which any community starts to use if it wants to be stable and to perform some sensible work.
That's actually related to what we discussed the other day about politics, because once the system becomes closed and stop, learning from the history, rewriting the history, things start falling apart. And so it is important to keep information log in it, because it's a part of your training, of any training model. You train on some data set, you should not just forget what you've been trained on. Revel, go ahead. We've got to be closing now, but.
Well, I was going to talk about intuition, and I just wanted to see, you're insistent upon using the scientific method, which I can appreciate this, but how can you determine what falls within the range of science and what does not? For instance, you talk about art, and this could, or and I talk, and fan of Carl Jung, talk about intuition, sensation, the collective unconsciousness or repository. Some of these thoughts are speculative, hypothetical.
So I think, Revel, this is the two things that are in thermodynamics are present: entropy and energy. And so by putting more crazy thoughts, it's very good for the learning system. The crazier, the better, right? You wanna try different theories, different ideas, and wanna throw them all in the basket. You should not dismiss them just because they sound crazy, because then we're gonna stop making progress. Now, at the same time, you wanna have this energy term. You wanna minimize the energy. You wanna minimize this temperature. You wanna be able to objectively filter. Not I say this, you say that, but let's sit together. Let's use a common language to figure out which theory works better right now, and then not dismiss other theories, but say let's write them in the language that is compatible. It's all about the language. If we agree on the language, I think it's very easy to make a progress, because we would not be discussing. We would be at least the communication channels would be there. So I'm against dismissing all ideas. I'm also against to use ideas just say, well, unscientifically. That's my plan. And then there'll be both. There'll be entropy of ideas. There's of how we model the environment, of how we model different phenomena, and there'll be a way of actually dismissing the ideas, not completely dismissing, just putting them on hold just because they are incompatible, and then also developing the ideas using the language. And as Victor said, and I keep saying this all the time, the language of neural networks allows us to do that, to actually describe all different ideas using a common language within which we can formulate theories and then dismiss them and then generate new and go on.
And how
you had said something.
How might the language of the neural network be able to something that the common person could use rather than just
no, but I'm sorry. I think the language of neural networks. We are now talking here using the language that normal people would understand. Actually, I haven't been writing any formulas or once in a while, of course, we use terminology, but that means that this terminology has to be extended so that people can learn it. Now, I don't think the neural network theory is too complex. Now, the results that you can obtain from that may be complex. The theories that you can build on top of, but as a language, I think it's pretty broad. Universal framework.
I mean, could you give an example? I would know if you were to have a conversation with an economist and you were to say, I have this language of the universe from my model, and how would you attempt to communicate that to him?
Right. Well, we already actually had, I don't know if we had about economics, but we will have it, right? And we'll be trying to do exactly that. So we'll be trying to describe what's the growth strategy of business should be using the language of neural networks, or what other aspects of business should be. How should you be building? Let's say, for example, should you be building a decentralized company versus centralized? Should there be a CEO has all the power, and then a hierarchy under it? It applies to economic system like businesses. It applies to politics, and we discussed it. I don't remember last time or the one before, that it is a disadvantage to have this, one head of the country that can become a dictator, or the head of the company who is a CEO, because the lifetime of such an organization may be short, very short.
I think when the United States was first proposed, I think when it was proposed that there would be 3 presidents and there was share power, but then it turned
Now, there is more to this. So actually, you can look at the spectrum of connections of people within the society. Again, it takes it off and say, well, this is not a working system. For example, there is one node and everybody's just listening to this one president who makes all the decision. This is very inefficient. You can look at the spectrum of this matrix. You see that has a very low rank. It is not capable of learning, adjusting to any environment. It's horrible. Yet it may be very stable for a short period of time.
So what would be your opinion of our tripart system of economics with the executive branch and the judicial branch and then Congress as an efficient system of government?
Yeah, it's a horrible, but the best we got, right? So just like democracy. So it has to be very different. So our discussion about politics was, we cannot go back now, but we will come back to this.
Okay.
That everybody should be just making decisions.
Sorry, I missed that one.
Based on what they know, right? So the problem is when we are just delegating roles to people to do some job, not based on their skills or my skills understanding their skills, but just because they're funny. Okay, so that's is not a good way for you to delegate your vote to anything. And so that system is not right. You have to use, everyone has to use their skills in whatever they're good at. And if they want to change, like, for example, if somebody was an artist and wants to become a politician, then they would have to acquire those skills that are needed for that. I don't know if there's much skills needed for being a politician, but that's a separate.
I'm going back to what you were talking about before with the all the ideas and taking all the ideas into account, and that is inherently why we are as a group so inefficient. Because the more ideas you take in, the more time it takes to process out.
Right, Donald.
Right.
Yeah. The main point for this group is not ideas, but the language.
Right.
Language. So if we can come up with a language as we can communicate with one another, then we can extend the group and, like, take this language to be more. We need a universal language.
Right.
This is missing.
That's a very good idea.
And how do you distinguish what is scientific, what is not? Is it a Popper principle or what?
Yeah, so again, I'm very flexible as a scientist. I'm not conservative at all, but I seem as very conservative from the outsider of a scientist. And my understanding is that you have, whenever you propose a theory or something or some idea, it doesn't need to have a immediate verification experimentally, but it has to have a potential. Okay, so you should have, like, for example, why is it very hard to come up with a psychological experiments? I keep thinking about that, because it's one of the things where you would want to potentially apply this theory is because we want it to be A, scientific, and that I can do, B, verifiable, right? So I want to be able to set up some experiment, which I can, like, plot a graph and say, okay, here it is. Here's the result, observational result, phenomena that I can check. And so writing a theory, for me, it's easy. Coming up with experiment that would test this theory is very hard because the more parameters there are, the harder it is to control that. But this is the direction we should be thinking, right? And so that would make experiment in any branch scientific. So
what would be one of the easiest other branches if you took a psychology and economics and politics to make a model and accurate?
Oh, no, it's absolutely. I started from the bottom. Mathematics, computer science, so understanding how computers work. Then I took to physics, how physical system works.
Yeah.
Then I took biology. I think I understand more or less how things there work. Again, not completely, but good. Of course, the next one is psychology. Because anything above psychology is harder. It's hard. The point is that you get all the previous phenomena and a bunch of new on every level. So it's every level comes with the surprises that something that didn't exist in a computer science level, machine learning, exists in physics. Something that didn't exist in physics exists in biology. And psychology is no exception. There are things that exist on the psychology level that didn't exist on the biology level, and that needs to be understood, modeled, and then somehow checked experimentally. And then unfortunately, the amount of rigor, mathematical rigor, in all of those branches from biology up are horrible. Just
What is your opinion? What's the next level after biology? Psychology or probably cognition is separate and simpler?
Yeah, psychology. After biology comes cognition, psychology. So everything we're discussing right now is kind of, but I keep thinking about the experiment. One of them I'm currently trying to do. I don't have results yet, so I cannot report on it. But this is the next step, trying to cook up an experiment on a psychological level where we can see the deviations from what biology level would produce, and that would tell us, here it is. Here's a new emergent phenomena that wasn't present in biology, but present in psychology. And after psychology, it will be economics, political systems, things like that. You can already model all this using the physics below, but you'll be missing essential parts. That I know for sure. Yeah. All right. That was a long meeting. Any final thoughts, ideas, comments?
I had really one question.
Okay, go ahead.
Heading into working in the field of psychology and trying to set up experiments and working with professionals in that context is going to be wildly different, I think, than say, well, considerably different perhaps than biology, for example, where people are almost on the same page. Because in psychology, we have 10, 20, 30 different theories.
Oh, they're not on the same page, Revel. They're not the same page, no. So the other problem we'll discuss at some lectures, it's a formation of cults and the formation of corruption. Unfortunately, the higher level, there is a more corruption and the more formation of cults, because they're less rigor. So if there's something is not verifiable, then people just start throwing their belief ideas, and then you cannot really dismiss them. And so not ideas that deserve more scientific evidences survive, but ideas who are belong to important people survive. And so that's why I'm very skeptical about all theories on those levels, unless, for example, I'm not going to tell you names, but in biology, there is a branch, there is a few people who are doing excellent calculations, writing very good papers in biology. And I can follow their formulas and their reasoning. And nobody is looking at those papers and nobody is citing them. Well, because biology is not created by the rigor, but was created by the, it works, right? It's let's try a few things. This worked. Okay. I mean, I will get more money. I will do more things like that. And so
I told my biologist that you said this, and he's like, "That's 100% true. It's not a real science." That's what he told me.
But this is what we want to do. We want to make real science of all those great, because the amount. But okay, but the good thing about biology, the amount of experimental data that they have is unprecedented. This is like, any scientist would dream about that much data. Like in any experiment that they do, just carefully analyze the data, do not do any cherry picking, and there you go, you are in business. And the same with psychology. There are a lot of experiments that needs to be explained and reproduced, and etc. So there's so much work to do. That's why I'm like saying we need to grow as a group, and at least we're not dying yet, but that's what we need, because there's a lot of work to be done in all those branches. I'm
gonna say, yeah, but maybe a lot of diversity in biology as well, and disagreement and that sort of thing, but even more. And then when you get into psychiatry, which I see as a pseudoscience, it's just.
But that's because, you understand, because of math, because of the rigor. If there's no rigor, people just say, well, I think this and I think that, and nobody can check who's right.
And well, that's what they do in psychiatry. There's this, we have this is, and it's anthropomorphic.
Okay, but now I'll say something very unpopular, but that's very dangerous, actually. How can you give advice, psychological advices, when you're basing it on not a precise theory, right? It's a.
I agree. I agree. It's actually a pretty terrible institution.
Yeah, and
it's
so
non-scientific.
I would say that this should not be allowed until we put more rigor. And
they're trying to go from before we've even begun to solve the hard problem, the consciousness to oh yeah, we know everything about psychology. It's just, no.
No, that's
You know, you
nonsense.
can't go-
That's nonsense. There's like so little we know about it, and actually, there's so many interesting phenomena that we know about. Like, I mean, it's we'll have okay. So
And if
you can
you
read
think
it.
if you
Next
think the
time we discuss
theories
psychology.
if you think the theories of psychology are bad, the practice is much worse.
Oh no, I know.
My
I know.
roommate is a psych nurse, and the stories she brings home is
No, I know.
insane
I
about how
know.
they handle it.
But there should be a
I worked in a
realization
prison,
about that.
Donald. I worked in a prison doing therapy.
Oh no! Oh no!
Yeah. I liked it.
Okay, guys, that was a lovely discussion, and of course, it was longer than 2 hours as usual. Although I always planned it to be 1 hour and a half, but hey, it was fun. We discussed a lot of fun stuff, and thanks for coming. I'll see you next week. Bye bye.
Bye bye.
Bye.
Thank you. Bye bye.